Today's topic is underpinning technique. In this topic, we will see following these 4 points. First, introduction. Second, conditions. Third, methods. And fourth, advanced techniques. Now, a building has 2 major components. One is substructure and second, superstructure. Superstructure includes walls, beams, columns, floor slabs, all those things. And substructure includes some portion of plinth and footing which is below ground level. Now, superstructure elements can be frequently repaired and maintained, but substructure elements cannot be maintained or repaired once it is constructed. Hence, over a period of time, it loses its strength and it may crack. This demands the repairing of foundation and footing. So the process of this repairing and strengthening of foundation is called as underpinning. It is a method used to increase foundation depth or repairing any faulty foundations. Suppose a building is resting on a weak soil at shallow depth, and now we want to take that footing up to the hard strata. Then the process which we will adopt or the method which we will use, it is called as underpinning technique. If we want to repair the faulty foundation, cracked foundation, then the process which we use to strengthen it, to retrofit it, it is called as underpinning. So it is a process of stabilizing or strengthening or lifting an existing foundation. Now, your foundation requires maintenance and repair. How this can be understood? This is indicated by the cracks in the walls. It is a thumb rule that if the crack width exceeds 1/4 inch, means around 6 to 7 millimeter, then this is due to the failure of foundation. So when such situation or such cracks are observed in the structure, it is the need of underpinning process or strengthening of foundation. Now, these failures can also be indicated in the form of buckling of walls or cracked concrete floors. This kind of failures we have seen in case of expansive soils also. Okay, because these soils are responsible for cyclic swelling and shrinkage. So this results into cracking. Similar kind of cracks we can observe in the concrete floor because of settlement of foundation or because of cracks in the foundation. So these are all indications that we have to go for underpinning process. Underpinning, it is a process of providing extra footings beside or below the existing footing. So we can excavate up to the footing depth, and then we can put extra footing beside it, adjacent to it, connected to it. This will increase the area on which the load is being transferred. So the SBC would be satisfied and there won't be settlement of foundation. Second, we can provide footing below the existing footing. So it is a very risky technique, complex technique of providing footing, new footing below existing footing. Now, the process of underpinning may be avoided. How? If possible, improve the soil properties. By improving soil properties using different ground improvement techniques, we can stop the settlement of the foundation. Once this settlement is stopped, the crack width, the cracks, the damage to the superstructure, it won't happen later. Alright. Now, conditions or situations in which this underpinning process is carried out. There are 3 conditions mentioned. One, when the footings for a house or set of units have subsided or dropped for a reason that is unlikely to reverse. Now, we have come across expansive soil, that is black cotton soil, which swells and shrinks with the moisture variation. So that means it is a cyclic process, it is a reversible process. But there are few processes which are irreversible, like collapsible soil. Suppose a structure is erected on a collapsible soil, and due to the moisture movement and variation, the soil is collapsed, the footing will get settled, and this becomes an irreversible change. Second is, a building is either being enlarged or converted for the use in a new type of activity, resulting in heavier loading than it was designed for. Suppose a building is designed for residential purpose and now it is required to be used for commercial purpose. So when a building is designed for residential purpose, as per IS 875, loads may be 2 kN per square meter. But when it comes to commercial, then the value of load may be even as big as 5 kN per square meter. So it is the 2.5 times more magnitude that will be experienced by the structure, magnitude of the live load. So that load would be transferred to the existing footing, but those footings are not designed for this type of heavy load. Hence we have to go for retrofitting method, that is underpinning method. Third situation is, a large new building with deep foundations or basements is being constructed close to an existing building, causing problems for the existing building. Now suppose a tower kind of building is being constructed beside your house, which is G+2. Now when deep excavations are made for such a high-rise building, the structure, the footing, it loses the lateral support because of this deep excavation, and there are chances of outward movement of this foundation, that is movement of foundation in the direction of deep excavation away from the original building, and this endangers the stability of your building. For such situation, underpinning process is advised. So we have seen three situations. One, when the footing gets settled. Second, when the utility of the building changes. And third, when deep excavations are made adjacent to your buildings or foundation, existing foundation. These are three situations. Next we have methods of underpinning. Basically there are two methods. One is improving foundation system and second is improving soil properties. This second method, improving soil properties, would be discussed in ground improvement technique, because in this method there are various ways in which soil properties are improved. So this method would be dealt separately. Method 1, that is improving foundation system. This improvement can be done in several ways. Now the first method is pit method. On your screen you can see there is a brick wall which is supported on the footing below. That brick wall basically is transferring the load. It is a load bearing structure, transferring the load to the footing and thereafter to the ground. So inner face of the wall is right face and outer face of the wall is left face. Now you can see there are two footings which are constructed adjacent to the existing footing. So these footings support this eye girder which is supporting this wall. This eye girder is passed through the holes which are made in the existing wall. So in what way now the load is being transferred? The topmost wall is transferring load to the wall in the foundation. That foundation wall is transferring load on the girder, and that girder is transferring load on the adjacent footings. This way the existing wall is made safe. Now further we can go for the repair. In second step you can see the excavation is done below the existing footing. Now you can say, sir, the footing would come down if you are taking out the support. But let me clear one thing. These excavations are not the continuous excavation below the footing. Basically it is done at some spacing. Okay, so this footing will not collapse immediately. So once that pit is excavated, in third step concreting is done below the existing footing. Thus that pit is filled with concrete. Now we can see the complete footing is ready. and it is supporting the existing wall. Now whatever holes which we have made to support the superstructure, that is the girder which we have passed across this wall, now it has been taken out, and the rest of the pit which is made for supporting this, it has been filled back. Thus all repairs are done and footing is now retrofitted. So this is pit method. Now the second method is needle beam method. Again same image we are observing. The right face is inner face and left face of the wall is outer face. In this method, two micropiles are driven into the ground. You can see in your image diagram. Okay, so two micropiles are driven into the ground. After that, excavation is done up to the head of the pile, and thereafter again same kind of hole is made in the plinth wall. Third step, a beam is casted which connects these two micropiles along with the foundation wall. Now if you observe this structure, you can very well imagine that these two micropiles are nothing but the supports, and this beam is nothing but a cantilever beam which is connected to the wall. So what happens? The transfer of load happens in this way. This vertical wall would transfer the superimposed load to this free end of the cantilever beam which is put into the wall. Because of this vertical load, the outermost pile that is provided at the second end, it will experience the lifting force. Hence the outer pile would be under tension and the intermediate pile or the inner pile would be under compression. So through this action, the vertical load would be taken care and less load would be transferred to the existing footing. In this way, damage to the footing or settlement of the footing can be prevented. This method is called as needle beam method, as beam is penetrated into the wall. Again, this kind of arrangement is made at some specific distance along the length of the wall. Next method is micropiling method. In this method, piles are made. Okay, those are made inclined below the foundation level. You can see in the image, the piling is done at some inclination just below the existing foundation. Then it is casted, or it may be precast kind of micropile. Thereafter, up to the head of that micropile, excavation is done, pits are dug out. Thereafter, soil below the footing and near the head of the micropile, it is removed. With the help of funnel, the concrete is poured into the gap. This way, now the footing, the existing footing is well connected with the micropile and it becomes strong enough to bear the load. Thus the complete load is now being transferred to the micropile. This way micropiling method is executed. Now the last part is advanced techniques in underpinning. These advanced techniques we will try to learn in the form of YouTube videos. We will try to understand how practically these engineers carry out this underpinning process. So just go through the links which have been provided in my course. Now let us summarize what we have seen today. We have seen what is underpinning process. Underpinning process is basically strengthening of existing foundation. This process is expected under three conditions. Which three conditions? First, when the footings for a house, they get settled because of some irreversible action. So there we require this underpinning process. Second condition, when there is change in the load due to change in the occupancy. When the occupancy of a particular structure changes and it results in increase in the load which will be coming on the footing, then underpinning process is advisable. What is the third situation? When there is a deep excavation around an existing building, then foundation or footings of existing buildings are required to be retrofitted and made stable. So there also this underpinning process is advised. This is carried out by two methods. One is improving foundation system and second is improving soil properties. Improving soil properties is the part of ground improvement technique. How this foundation system is improved? So it is improved by three methods. One is pit method, second is needle beam method, and third is micropiling method. In pit method, with the help of proper supporting system, the load from the main wall of a building is relieved and it is transferred to the temporary foundation, and the existing foundation is retrofitted or strengthened by putting extra concrete block below the existing footing. In that way, pit method is executed. In needle beam method, a beam is casted underground which goes directly into the main wall. That beam is supported on two micropiles. Those micropiles take care of complete load of the building, and that load is transferred from the walls to the cantilever beam and from the beam to the micropiles. In micropiling method, an inclined pile is driven below the footing and the gap between the existing footing and micropile is filled with concrete. Thus, existing footing and micropile together will act as a single footing, single entity, and takes the complete load of the building. This way we have seen these three methods of underpinning. So that's all for today. Thank you.